This is episode 4 in the series about our contribution to the pipeline foundation for the project pydeps. Check out the dev container image deployment in the previous episode. Hi, I'm still Alex from Singlet, and in this video we will cover the configuration of the build agent image for the core continuous integration and continuous deployment pipeline. Let's get into it. In GitHub Actions, out of the box, you get several VM configurations with a huge amount of tooling pre-installed on which to run your pipelines. They are kept up to date several times a month. These configurations are great because they cover a wide variety of use cases. However, to ensure that the pipelines for your specific project are bulletproof, you need to have a clean, tightly controlled and encapsulated environment that is independent from the outside. That means that your specific development tooling with the specific versions is clearly defined in a configuration with a clean base without any unnecessary components present. A great way to do all of that is running the pipeline inside a container, the image for which is defined and maintained by the owner of the project. This will ensure the smoothest development and the most solid consistency between development and production. Here is the image configuration that pydeps required for its continuous integration and continuous deployment. The base as it is for the entire DevOps infrastructure of pydeps is Ubuntu 20.04. The argument on line 4 instructs apt-get's interface to behave non-interactively and automatically receive default answers to questions. The arguments on line 5 and 6 are used to differentiate between the 6 separate images that this configuration could output. The project requires an image for one of 5 different Python versions for continuous integration and one for Python 3.9 for continuous deployment. As mentioned in episode 2 of the series about the dev container image configuration, all commands are defined in a single run declaration for optimal image size. On line 8, set-x enables a mode of the shell where all executed commands are printed to the terminal. On line 10 are installed a few packages that are required by the build process and execution of the pipeline. From line 13 to 53 are executed the installation of Python 3.6, 3.7, 3.8 and 3.9, which is done by compiling Python from a source and the installation of pip from the get-pip bootstrapping script for the respective Python version. For more information about this unconventional installation of Python, check out episode 2 of this series. From line 26 to 39 are defined the latest package tags for each Python version to be used in the download command on line 40. From line 54 to 73 are handled installations specifically for continuous integration. On line 56 is installed GraphViz, which is used by the unit tests. On line 58, if the Python version for this image is 2.7, it is installed the conventional way through apt-get, and also pip is installed through getpip.py. On line 65, if the Python version for the image is 3.9, the lightweight JSON processor JQ is installed, and also the Flake8 and packaging Python modules, all of which are involved in the packaging of the project. From line 73 to 82 are handled installations for the continuous deployment. First, the latest version of GitHub CLI is installed, which is used for the GitHub release deployment, and the Python module Twine is installed for deployment of the project package on PyPI. The output of this Docker file is intended to be one continuous integration image for each of the Python versions 2.7, 3.6, 3.7, 3.8 and 3.9, and one continuous deployment image for Python 3.9. If you've watched episode 2 of the series, you would probably have noticed that there are quite a few similarities between the dev container image and the build agent image, but they are still in separate Docker files. The only reason is because of how the contributions were made. Combining the two Docker files will be a definite improvement, since it will decrease the overhead that maintaining the same chunks of code in two separate files creates. In this episode, we looked at the build agent image configuration. We discussed the rationale behind its creation, the tooling installed, and what the end result of the configuration is supposed to be. We also discussed a useful improvement about reducing maintenance overhead coming from having separate dev container and build agent image configurations. Stay tuned for the next episode in the series where we discuss the deployment of the 6 different images that the build agent image configuration produces. If you need assistance with DevOps implementation in your open source project, check out the description of this video where you will find links to the Pipeline Foundation project board and onboarding application submission. We are at your disposal. Thanks for watching. If you have any thoughts about this video, please let us know in the comments and feel free to like, subscribe and strike the bell if you'd like to hear more from us. Until next time, stay safe and aspire to DevOps.